Hello, everyone, and welcome to the AQUALIS Sustainable Water Compliance Summit session, a retrospective on green infrastructure, lessons learned in design and implementation. I am Katie Johns, Editor-in-Chief of Stormwater Solutions. To begin, let me explain how you can participate in today's event. First of all, if you have any technical difficulties during today's event, please put your question in the questions window and our technical experts will help you out. We recommend disabling any pop-up blocking software or extensions in your browser, as these can cause issues with the webinar player. Additionally, we welcome your questions during today's event, and we will answer as many as we can during the Q&A session that will follow each session. But please feel free to send in your questions at any time. To do so, simply type your questions into the Ask a Question window on the side of your screen and hit Submit. Also, please be aware that today's event is being recorded and you'll be notified by email when the archive is available. At the conclusion of the webinar, you will receive an email with a link to download your certificate, which can be used to submit for credit with Stormwater University or serve as one personal development hour for attending today's webinar. Certificates will be sent to attendees who viewed this session for at least a minimum of 50 minutes, 50 minutes. For those viewing this session on demand, you will need to complete and pass a short quiz at the end of the session to receive your certificate link. And now let me introduce you to the session's presenter. Matt Prusko is a senior project engineer with Arcadis. He has more than 12 years of experience specializing in civil municipal planning, design, and construction support, specializing in water, wastewater, stormwater, and land development projects in both the public and private sector. Mr. Prusko resides in Philadelphia, Pennsylvania with his wife and their 2 children. So with that, Matt, it's all yours.
Thanks, Katie. Hello, folks. Hopefully everybody can hear me and you're all having a great day. As was mentioned, I'm Matt Prusko, a senior project engineer at Arcadis, and today we're going to review some lessons learned in design and implementation when it comes to green infrastructure projects. So to start with, we'll look at a quick agenda, and as you can see, it'll cover a brief introduction and we'll go over a history of water management before we look at GSI design in both the public and beyond the right-of-way as opportunities, as well as looking at GI as an asset before we go into some questions. So my hope is that you're going to find this presentation engaging, interesting, and you're going to leave the call with a few key takeaways, including learning about GI and its uses for flood and CSO reductions, as well as water quality improvements within the public right-of-way. You'll understand where and how to find opportunities for implementing green infrastructure outside the public right-of-way, and get a sense of some of the common challenges and lessons learned associated with GI design. Lastly, we'll focus a little bit on viewing green infrastructure as a vehicle to get more done. Stormwater management doesn't have to be viewed as a regulatory hurdle. Let's start with a history of water management. In the beginning, don't worry, sorry, I know this is a virtual presentation, but I couldn't resist trying a little bit of humor. We only have an hour and I'm not going to spend a lot of time on this topic, but I kind of wanted to frame the conversation with an understanding that water management's been around for hundreds of years. This is another slide with a couple of examples that kind of carry forward that idea. And this is really just to help contextualize that stormwater management's not really a new concept, but it's one that's becoming more and more regulated. This slide is actually where I'd like to start today. It's a good slide that kind of shows the evolution of stormwater management in the United States, and you'll probably recognize a lot of the buzzwords from over the years. Regulated stormwater practices can be kind of traced back to FEMA when they began regulating floodplains in the 50s, and obviously a lot of people are very familiar with the Clean Water Act in 1972. The 80s saw the beginning of industrial stormwater permitting, and the 90s was when MS4 permitting was brought about. But the shift to green infrastructure really began in the year 2000 with the publication of the Maryland BMP Manual, which was a landmark publication that introduced the concept of low impact development and set a lot of the groundwork for where we ended up today and kind of where we're heading in the future too. So in the modern times now, we're shifting to green infrastructure strategies that aim to return sites to the natural hydrological condition and treating stormwater at the source. We've shown on the previous slide a timeline that illustrates this change in our stormwater management approach, but I'm sure everybody's kind of wondering exactly why we made the change in the approach. This slide's an interesting visual to illustrate that shift in thinking with regards to stormwater. Traditional stormwater management approaches offer poor control of the smaller, more common storm events, and in fact, largely those things are being neglected altogether, and our traditional designs allow them to pass through a system unmanaged. These more regional approaches really focus on those large, less frequent events. I'm thinking like design storms that people are probably familiar with, the 2 through the 100-year design storms. But if we look at this figure on the right here that shows some rainfall totals in the state where I'm from, Pennsylvania, we see that almost 65% of the rainfall events are those that result in a depth of 1 inch or less. And these storm events are the ones that would typically pass through a traditional design basin that was designed to handle the much larger storm events, like typically in excess of 3 inches. So green infrastructure mimics the natural hydrologic condition of a site, and typical GI practices are designed to manage low intensity, high frequency stormwater events. Green infrastructure practices are meant to mimic that natural hydrological cycle, and the practice on the right here is what I would describe as the typical bump out. A lot of people have probably seen this. It collects gutter flow from a roadway surface, it ponds water within the surface storage area, and then stormwater can draw down through the soil and into an underground trench or storage media. And that filtration through the surface soil has a tremendous impact on improving water quality, as opposed to traditional gray infrastructure on the left here, which is collecting dirty runoff from a street and quickly trying to convey it to a nearby body of water. So we're moving away from those large surface detention basins that are slowly releasing runoff and moving towards infiltration practices where we can. And what we see here on the right is a StormTech arch system, and those function like detention basins in that they can provide rate control, but they're also providing volume control as well by having an open bottom. Typically, you'd see these placed underground below parking lots, and in some instances, people utilize them for conveyance piping too. So now we're kind of arriving at green infrastructure and how it's different from that gray approach. Some of the major benefits of green infrastructure practices are you're treating stormwater at the source, you're eliminating the costly detention basins that utilize a lot of valuable land space. We're not going to allow stormwater to get back into the aquifer unless we use recharge practices. We need to think of it as a resource, stormwater that is, and not a waste product. And we're also reducing energy demands by mitigating the urban heat island effect that's usually traditionally seen with large expanses of asphalt. And lastly, there's a societal benefit to green infrastructure. As we liven up a space, it kind of fosters a sense of community within the neighborhood. So let's talk about GI design first, focusing on right-of-way green infrastructure. And I should be upfront here. A lot of these photos that I'll be sharing today are from Arcadis projects, but not all are. Some are from my own neighborhood where I live and can see some examples, and others are just really interesting projects that I've seen over the years that I think help tell this story. So this slide illustrates examples of GI practices that can be available for designers to implement in the right-of-way specifically. And there's various ones to choose from that really apply to your given situation. It can be a bump out like we just described, or planters, or porous pavements, or anything else that's on this list. And what I really kind of want to focus on with this graphic is it's an interesting visual about implementing GI into a specific space. And in this case, it's the right-of-way. With GI, we're going to work with smaller drainage areas and view stormwater as a resource, like I said before, and not a waste product. And we're going to manage the stormwater on site as opposed to conveying it far away. By managing the runoff on site, you're going to promote infiltration, evapotranspiration, evaporation, all those typical processes that are a more natural cycle. And you're going to be improving water quality because you're giving the stormwater a chance to be filtered through a surface soil or some other kind of media. And the list isn't exhaustive, don't get me wrong. I think this is just an interesting way to look at a toolbox, but we should also be comfortable stepping out and using our imaginations to kind of tailor a design to the specific space that we're in. So from a designer's perspective, there's significant considerations that we need to be keeping in mind when we're tailoring green infrastructure to meet our site-specific issues. And these can range from, identifying those program or site-specific goals to how we evaluate that drainage area to what kind of pre-treatment should be utilized. And we'll step through a couple of these things over the next few slides. So as a design engineer, I'm interested in solving problems. I'm interested in achieving goals for a client, for a project. For green infrastructure projects, it's important for designers to be thinking about the municipality that you're working in or the organization you're working for site-specific or program goals. So on this side of the slide here, I'm going to be using the Philadelphia Water Department as an example, but you'll see similar situations in other municipalities across the country as well. One of the key metrics that you see used a lot when evaluating green infrastructure is a green acre, which for those who aren't familiar, when we're talking about green acres, they're a given area of stormwater runoff that ends up being managed by a green infrastructure practice instead of being captured and handled by the combined sewer system. Another design consideration that we should be looking at gets informed by geotechnical investigations. So geotech investigations are important because they establish the subsurface soil characteristics. They help us identify any hydrological limitations. Bedrock or groundwater are two examples to be thinking about. GI practices can still be utilized when you have areas that have poor infiltration rates. In that case, you'd be utilizing a slow release type of design to sort of detain and slow down how quickly water leaves those systems. What's interesting about this slide too is that graphic that I'm showing. It's a color rendering and it's a base plan at an intersection in New York City where Arcadis was designing right-of-way green infrastructure systems. And one of the biggest challenges of designing green infrastructure in the public right-of-way is avoiding utility conflicts. And as you can see in that graphic, the public right-of-way in an urban area can be particularly challenging. It's not going to be very cost effective to relocate utilities to accommodate GI practices. So we have to figure out ways to design around them. In some instances, it's important for designers to be utilizing subsurface utility exploration or ground penetrating radar to help locate existing utilities. It's good to know that up front because it can avoid some costly challenges in construction for unplanned conflicts, or even worse, if something was accidentally damaged during construction. Another design consideration for GI practices that's really critical is just location, right? Your practice, you should be aiming to capture the largest area feasible for a system. We can't design effective stormwater practices if we don't get sufficient inflow to a system. In a right-of-way, an urban setting, we're typically going to be looking at an end of a block. That's preferable to doing something in the mid-block or further up the drainage area because you just want to maximize the area that you're managing. A controlling factor to also be thinking about, particularly for infiltration designs, is loading ratio. And if you're not familiar, loading ratio, when it comes to green infrastructure, it's just another guideline that you have to be thinking about for sizing an infiltration footprint. And usually you're just considering the ratio between the drainage area you're managing and the available green infrastructure practice footprint. So there's a couple different collection methods that are typically used for green infrastructure. Typically it's done with a green inlet or a curb. Green inlets, they're no different than a regular inlet. It's just that they're conveying the runoff to the GI practice. instead of the sewer itself. One that you may sometimes see if you're at the corner of an intersection is a dual trap, which can be used simultaneously to drain a low point and also route stormwater into a green infrastructure practice. And lastly, this goes without saying, but O&M considerations are super critical for thinking about designs, because we really need to be ensuring the longevity of an infiltration practice. And to do that best is using some sort of pre-treatment. When it comes to sizing your green infrastructure system, like we talked about a few different ways at this point, it's identifying that drainage area you're managing, making sure that you're thinking through the local goals of your project and managing that 1 to 2 inch depth of runoff manage. You also should be thinking about what kind of drain down time you'll need for your system, and in looking at that too, considering what kind of overflows or under drains might be necessary to ensure a safe design. It's also really important to be thinking about the soil you're using for green infrastructure. And this slide kind of has a typical engineered soil recipe mix. I think the big thing to be thinking about is making sure that when it gets to construction, contractors are installing these systems aren't just using the backfill that was excavated or stop on over at the local hardware store or Home Depot to pick up a bag of builder sand or polymeric sand for a system. There's two big issues that pop up when that happens. The soil mix may have too much silt, or if the clay can melt in a ponding situation, and then the storage area gets clogged. Or the wrong type of sand could lead to a situation where after the sand gets wet, it actually becomes a glue and hardens and just renders the system unusable. There's landscaping considerations to be thinking about for green infrastructure too. Your selected plantings need to include native species. And public outreach is super critical for community buy-in at a lot of these practices. One of the common questions I feel like we hear all the time are, why are these weeds being planted in front of my house? And it's not that they're weeds, but we need to educate people and let them hear from us to learn what's important inside of those things, and really hammer home that this green space offers a chance for beautification and for getting the community involved. Another big issue to be thinking about is the safety, right? So many green infrastructure projects, green streets, right-of-way, bioswales, bump outs, those types of things, they're all usually located in the street. Rain gardens are often designed in parks where you'll have children and other users interacting with it. And green infrastructure is often installed on public property. I'm thinking town halls, community centers, things that are frequented by residents and municipal employees alike. Improper design and maintenance of those features can lead to things like tripping hazards, aesthetic issues, traffic safety issues, health issues. So we need to be thinking about some of those safety considerations when thinking about green infrastructure for our projects. So there's many, many safety hazards that can arise in design that we need to be thinking about. Can be improperly designed drawdown times, which lead to stagnant water and insect breeding grounds. Curbs, curb cuts, anything with a large vertical drop or an uneven transition can lead to a tripping or a fall hazard. Trash is the big issue. Entering the green infrastructure facility or just being unsightly and limiting the performance of what the practice can do. Another thing we'll touch on is the lack of roadway striping or signage when you're changing traffic flow in these areas because of a BMP, and how that impacts driver safety. And I'm also thinking about things like improper viewing angles for a vehicle at an intersection, or just the pedestrians utilizing crosswalks. So getting into some of these things, starting with essentially minimize the poorly draining water. I think, like we've mentioned a few times now, there's two safety hazards to be thinking about, and that's stagnant water and drowning issues. The potential for drowning is definitely a consideration to be thinking through when you're doing one of these systems where small children might be present, because it's important to think about you only need to have a few inches of waters where a person can become a victim of a drowning issue, unfortunately. Also, mosquitoes breed in shallow, stagnant water. So it's important that our designs detain, or I should say, as they detain and retain stormwater, we make sure that we're doing what we can for drain down to avoid breeding grounds for mosquitoes, which are both a health hazard and just really a nuisance issue. And a lot of these systems, you're really targeting a drain down time of 72 hours or less. Sometimes that's even driven more stringently by local codes, ordinances, and things like that. In terms of providing proper edge conditions on surface green infrastructure, particularly for rain gardens or the bioswales, bump outs, those types of things. One of the key things here is that your terrain is really going to dictate the design of the system, but we want to try to avoid steep slopes as much as possible. Side slopes, they need to be gradually sloping banks. 3-to-1 grade is usually acceptable, and when you could do better than that, we should. When possible, if a facility has a steep side, we want to locate that away from a pedestrian route. And as the photo here on the bottom shows, shallow curbs between the sidewalk and a green infrastructure feature may look like they provide a visual barrier for somebody walking there, but we've actually heard stories from clients that they end up more often than not being a tripping hazard. And that's usually due to people just walking around paying attention to their cell phones or not thinking about where they're going, or just being distracted in general. An interesting story actually here about this next slide is a result from one of our Midwest clients that told us that they were really considering not using green infrastructure in any of their streets or rights of way, because they had an issue where a car drove through a curb cut and into the green infrastructure practice, and they got a ton of bad publicity from this event. So you can kind of think through the potential damage that can occur to a vehicle. If you take a look at this photo here, if a vehicle here would back up too far in that parking spot, that left tire is going to go right through that curb cut and drop down into the gravel area. These open curb cuts aren't just problems for vehicles and drivers. Sometimes, in some instances, a pedestrian or somebody using a bicycle might think that's an entrance to a sidewalk or a ramp or something like that. So a solution that we found to help prevent cars and cyclists and pedestrians from driving or riding or stepping off into the green infrastructure is using a steel curbed wheel stop in that photo on the right. If that steel curb wheel stop had been used in the first photo here, a driver backing up that doesn't see that green infrastructure, they would at least have their tire make contact with that steel curb before backing all the way into it. And that steel curb wheel stop on the roadside of a green infrastructure practice really provides an extra visual barrier for cyclists or pedestrians that, hey, this isn't really an entrance for you to be utilizing. Excuse me there. Another common design issue are deep vertical drop-offs from the curb to the bottom of a green infrastructure system. And we really want to be thinking about the two sides when designing for these deep vertical drops. You want to be thinking about what's happening adjacent to a parking lane and what's happening on the pedestrian side. So for a lot of the downtown or urban areas with parking lanes that are adjacent to green infrastructure, this could be a major issue for safety in both dry and wet weather. And for newer designs, what we've been implementing and seeing around the country is that green infrastructure should be set back further from the curb, kind of like you see in the photo here, with grates that can cover the channel that convey the stormwater from the street into the green infrastructure. Or two, what we've also seen, the photo on the left here, is that you'll have a row of about 6 or 8 inches of gravel added to the GI feature, which gives a spot for somebody that's exiting a vehicle to step off without getting their feet wet too. And on the pedestrian side of green infrastructure, many cities use things like fences or decorative railings to prevent pedestrians from accessing the green infrastructure. The access deterrent, it's a visual thing, right? But it also helps people eliminate that issue of the vertical drop in general. I think a lot of local areas will tell you that you need to have some sort of fall protection, like a railing or a fence, if you've got a vertical drop of 30 inches or more. Like we discussed earlier, trash is a huge issue. Things like cigarettes, candy wrappers, bottle cans, whether they get washed into a system through a storm event or they get thrown in by a pedestrian, it's a major issue. Green infrastructure needs to be designed with a 4-bay area. You can put a screen, a filter, or similar pre-treatment type device to help collect that trash. It also can act as an energy dissipator, and it also is a spot to make maintenance easier. It will simplify removing all that collected debris and prevent trash from collecting inside it and limiting the green infrastructure performance. Trash can also clog engineered soil or can clog the underdrain, and then you have that issue with stagnant water again, like we talked about, and that's where we'd be concerned about drowning issues or insect breeding. One thing that some municipalities have adopted is putting collection bins next to the green infrastructure if possible, because it kind of helps discourage people from throwing things in the green infrastructure if they can see there's a trash can to put their rubbish. One other issue that wasn't really addressed as much as it probably should have been in a lot of earlier green infrastructure installations was just proper identification about changes to traffic flow areas where green infrastructures were added adjacent to a roadway. So a lot of these green infrastructure practices can be utilized for traffic calming measures, which helps to reduce speed and traffic volume. But those changes can impact the perception of drivers and in some ways decrease safety at first. So it's really critical that we provide appropriate roadway striping, like you see in this photo here, or extra signage or reflective posts wherever it's necessary. While adding green infrastructure features that infiltrate and store stormwater is a very key feature of GI in the right-of-way, adding things like street trees or a large bush in the sidewalk can also create an obstruction to a driver or the pedestrian. You can see in this photo here that poorly planned and designed green features can actually obstruct a driver's ability to be able to locate a pedestrian. And we need to be thinking about providing safe viewing angles for vehicles at intersections and for pedestrians at crosswalks. You can see that photo on the right here is a little bit more of a cleaner example of how you can avoid creating blind spots. And finally, a lot of urban green infrastructure programs, especially in major cities, are locating their SMPs and urban rights-of-ways. It's important to think about the changes to the sidewalk, to the crosswalks adjacent to these GI features, and ADA ramps. Anytime you have a ramp that's affected by new installations, we should be also thinking about upgrading the existing ramps to be more ADA compliant. And sometimes you need to be thinking about those that are close to, but not necessarily right next to green infrastructure too. Let's kind of move on from the right-of-way and start talking about options outside of the traditional right-of-way. And all of these concepts that we'll be talking about now are centered around thinking beyond the streets. So a couple examples to be considering here are large medians or vacant lots, parks, playgrounds, and other public works area are opportunities too. And in some instances, we've actually seen utilizing front yards in residential neighborhoods as an option. So what are the benefits of looking beyond the right-of-way? You get a much larger surface area. So there's a possibility to take in more drainage area without blowing out that hydraulic loading ratio we were talking about earlier. And generally, you have a lot less utilities than what you'd find in the streets. We don't lose existing features that sometimes detract people from green infrastructure in the right of way, like parking. You're not going to change traffic patterns. You don't have to worry about those ramps we just talked about. Instead, it's a chance to maybe enhance an underutilized or bleak space. And I've got some examples that I can show over a couple of slides here. And lastly, because you're in an area that's likely less congested by traffic or utilities, the construction costs can be estimated to be a little bit lower because we're not going to be rebuilding roads or sidewalks or dealing with so many of those conflicts. And here you get an even bigger benefit, like a double whammy of managing both public and private property. I think we should also take a minute to think through some of the challenges working outside the right-of-way too. Land ownership's a big one because it's not always something that's typically available, especially for municipalities. Also, there may be use restrictions on land too. Conveyance is a big issue, and we'll show some examples of that in a couple of slides here too. And another thing to think about is while we want community engagement and action, not all neighbors really appreciate that. And when you add these green spaces, it's going to attract more people to these locations. And some folks just don't want the extra visitors in their neighborhood. And lastly, elevation is a huge issue because typically roads get cut in and then you surround those roads with lots that drain to the road. So that can be a challenge to think about overcoming. I think it's a good space here to start talking about the vacant lots in general. This slide does a good job of showing how you can transform an underutilized space into something that's got a lot more visual aesthetic. And corner lots, you can't always develop them effectively, but one of the benefits of siting green infrastructure at a corner lot is you have an opportunity to manage stormwater from 2 streets instead of just 1. A big thing here that I'm going to highlight on the next slide we take a look at is going to be GPR again. So this is kind of an example from a project I worked on that hopefully everybody here can also learn from too. The photo on the left here shows that vacant lot that was selected as a potential green infrastructure location. We did survey, we did base plan, we did geotech investigations. We finalized the design for the site. The issue actually didn't come up until we got to construction. And the contractors, as you can see from these photos, found a residual basement foundation wall within the vacant lot. It was just one of those situations where the geotech investigation that had borings and infiltration testing, none of those tests encountered this issue. And it just wasn't something that was found until it got to construction. So after this, the lesson learned, the takeaway here was we more regularly utilize things like ground penetrating radar as just part of the regular process at vacant lots to see if an issue like this will pop up. We'll go back to something that I think is a little bit more exciting, and I like this one a lot. It's a great example of a vacant lot green infrastructure system, and it's located right by my house, actually. It's a subsurface storage area with a rain garden component, and it's really interesting because it's a neighborhood favorite, especially in the spring and summertime. I take my own kids here. It's a site that sits on a commercial corridor. There's restaurants, pizza shops nearby. There's always tables and chairs that are placed here for the community to sit and enjoy the space. And it's attracted things like food truck festivals and community events. But the real important thing is that it's managing runoff from the lot, but also from the public right of way as well. Large medians, things like triangle parks, these we have all over Philadelphia where I live, but you can see them in other places like New York and Washington, D.C. too. And it's really just a result of a boulevard that bisects a gridded network of streets. These are great spaces for considering green infrastructure. because often it's underutilized, but community members do use it for focal points, for gathering points for activities. And like the vacant lot, oftentimes you can get multiple drainage areas from different streets, and usually there's not as many utilities to deal with. Some other areas to think about for green infrastructure beyond the streets and outside of the right-of-way, but these areas are typically abundant in cities, are existing parks and playgrounds. I like this graphic because it kind of details a whole lot of benefits when developing green infrastructure and other programming in these spaces. Playgrounds, in particular, provide a really good opportunity to connect the community with the work that we do and with the parks themselves, while providing this awesome space for a green infrastructure project. One thing that we do on a lot of our projects is add educational placards, because it kind of helps the public know what's below and why you should or should not be walking through certain areas of the park where they have rain gardens. In other communities, maintenance and litter patrol ends up being taken over by local residents who really value this installation that ends up near them. The photos on this slide are from a project at Cool Spring Park in Wilmington, Delaware, and I'm going to talk more about that later, but these are great examples of signage that can be installed. So the ones on the left were the educational signage that was installed for the specific green infrastructure practices. And the photos on the right, I think, are really impactful. The story behind those is the local school actually held an art competition that was sponsored by a nonprofit for the students to provide a way to do community awareness for the green infrastructure installation. And it just so happened we weren't really aware of this happening. And I ended up walking the site with the city's public works team, and we found these things, and we were all really struck with how wonderful it was to see local stakeholders taking ownership of that green infrastructure and providing that community awareness piece. Another really unique spot to think about that's outside of the right-of-way can be a large shoulder area or a front yard. And the photo here really shows an example of a situation that we encountered a few years ago, where the shoulder and part of this person's front yard ended up with nuisance flooding that would pop up and that would result in freezing issues in the wintertime as well. So you can see how this space, this front yard area, got transformed into a green infrastructure opportunity. It eliminated that nuisance flooding, it beautified the area, and it worked really well because in this situation, there happened to be minimal utility conflicts right next to the shoulder in the front yard, and we had a very committed resident that was interested in seeing something like this. So we've been looking at some design considerations and challenges and examples of green infrastructure within the right-of-way and beyond. I think next we can start looking at a couple of examples of recent projects where green infrastructure was really used as a vehicle to get more done. And I'll show you a few examples of what I mean by that. The first project that's really interesting I can share with you is one at Cool Spring Park in Wilmington, Delaware. And I talked a little bit about it before. For some background, the park is located adjacent to the historic Cool Spring Reservoir, and it's really an urban oasis that's used by the local community and by a couple of schools. The aerials that I'm showing here at the right kind of show the park's transformation over the years. You can see the original reservoir, which is the top left portion of the top left photo, and the park also at the top left, but on the right side here. And over the years, that reservoir and park underwent a bunch of different improvements to cover up the open area of the reservoir. And during the construction of that, the park area ended up getting utilized for staging and storing items for construction. And so those existing soils really got over compacted. So fast forward to 2018, and the Cool Spring Park now regularly experienced flooding issues when even a minor storm event came through, and it would render the park and a lot of the playground spaces just unusable. So this affected 2 local schools. It affected the Parks and Recs department, the community groups that used the spaces, and they had farmers markets that happened there weekly, carnivals, food truck festivals, things like that. So it was a situation where the Department of Parks and Recreation and the Public Works Department decided to partner with a goal to address this flooding issue. This slide has got a ton going on, I know, but overall, I think it's going to tell a really cool story about the collaboration that occurred throughout these stakeholders. Just as a quick reminder, the minor storm events resulted in flooding within the park space, and it just negatively impacted anybody that was trying to use it. North Van Buren Street is located on the west or the left side of this exhibit, and that had an existing driveway apron and sidewalk for accessing the site. It's on the high side of the park. What may be hard to see from some of the photos here was that right-of-way runoff wasn't being captured by the existing inlets efficiently. And this created an opportunity for that right-of-way runoff to get into the park. So that was actually making the flooding worse during rain events. And you can see in the bottom left photo here, this is just a small typical rain event that happened in the city, and the playground would be flooded and unusable. So Public Works and the Parks folks both recognized that there was a chance here for them to work together. From the Public Works team, it's important to know that they made a bunch of commitments as part of their city's long-term control plan to implement green infrastructure as a means of source control. And the Parks and Recs folks, they've been evaluating this park location for improvements as part of a master planning effort. Within that master plan, they'd engaged with several community groups and gotten input. Those groups really wanted to see green space, they wanted to see outdoor classrooms, they wanted to see improvements so that way this flooding wouldn't keep happening. And the timeline at the bottom of the slide kind of describes how these ideas all came together in a way where stormwater and green infrastructure improvements could be initiated while they were still doing some of the playground planning phase. And what this did is it allowed time for a comprehensive GI design that would provide relief for the flooding concerns, but it would also be an opportunity to integrate with the rest of the park renovation plans. And now that had begun with the master planning that had started in 2017. So these green infrastructure improvements were done in parallel, and then the playground relocations, the planning there, made it opportunities for more visible displays of green infrastructure, like you can see on the right here. The improvements that were designed and implemented here were bioretention planners that managed right-of-way runoff, and they nicely actually framed the entrance of the park. And there was also a rain garden that replaced the overly compacted soils in the one corner. And the rain garden area is really interesting because it's planned to become the beginning of a larger green infrastructure feature that's going to be added in future phases of the improvements to the park. And they're looking at using it as an outdoor classroom space. So what are the overall project outcomes to kind of take away as lessons learned here? Like I mentioned, the green infrastructure, we sited it to intercept the stormwater in the right-of-way before it could enter the park. So that made a safer condition. It also addressed one of the long-term control plan goals for the city. And given the timing of the engagement between all these stakeholders, that visible aspect of green infrastructure was implemented, and it made a space for the public to interact with a green space. And that led to that unexpected but a really cool, satisfying situation where just a year later, the community and the Parks and Rec team, they chose to change their master plan after interacting with the space to relocate that playground that I've been talking about before up to where these green infrastructure practices were. Since Parks and Rec provided a space in their park, in their master plan for Public Works to site this green infrastructure, and that addressed the long-term control plan goal, that allowed the parks folks to reallocate some of their budget dollars within their master planning effort to do something a little bit more. So the photo on the bottom here was taken after all these playground improvements were completed. And you can see in the background section, the street, that North Van Buren Street I mentioned before, where the GI was installed. And the photo always makes me do a double take, because when it was originally shared with me, I thought that was a rendering and not a photo. It's that unique of a photo, in my opinion. So anyways, given the opportunities for green infrastructure at the park and the fact that they still have more master planning improvements planned for the park, it's a place where the city can keep partnering across departments to share budget dollars and get more done using GI as an asset. The last example I want to talk through today is utilizing green infrastructure as a vehicle to get more done can be found at another project in Wilmington, Delaware, called the Urban Artist Exchange. This project ended up being a collaboration between the Department of Public Works again, and City Fest and the Urban Bike Project, which are two organizations that are utilizing the city-owned parcel. It was previously a kind of an abandoned parcel, and it once housed the Wilmington police stables, which we show in that top photo there. And this has been renovated since this photo had been taken. It's transformed the space. It's become like a cultural arts center for the community and a performance venue. So the story here begins actually further back than just the site itself. There were two housing developments that were called Walnut Ridge and Walnut Place. And when they were being constructed, as with most developments, those developers needed approvals and permits. And while reviewing the development, the city's Department of Public Works identified an opportunity here to see if the developer would install separate stormwater piping at these housing developments, with a future goal of managing that runoff from the sites onto the city-owned parcel. As the green infrastructure planning and design for the site kept continuing, more projects were also coming online in this area with other stakeholders that ended up requiring even more coordination. One of them was a roadway widening project, a repaving project with the city streets department, and that actually included the segment of 15th Street that was bordering our site and right above one of these developments. And then lastly, like I mentioned before, the two groups, City Fest and Urban Bike Project, were already looking at rehabbing the site themselves a little bit. So the Department of Public Works here acted as a connector between all these different improvements, and the planning across these four projects really coalesced into a really cool opportunity for each of the stakeholders. Let me give you an example of what I mean here. So on this slide is a preliminary site and programming plan that was developed by the City Fest design team that was rehabbing the site. It was kind of cool. They were looking at repurposing those stables for art spaces on the north side of the park. They had an outdoor sunken amphitheater on the southeast side, and there were tracks and paths and driveway improvements that could be used for different programming activities. Take note here, though, that there doesn't really seem to be a whole lot of stormwater planning in this concept. Because of that early engagement with Department of Public Works and the different stakeholders that they were involved with, all the different design teams were able to meet up, discuss what their project goals were, and then collaborate to get more done than each of them had kind of planned originally. So this slide here shows that same site, but now the preliminary site and planning plan was developed, and it's got way more to it than it had before. So now there's a much larger performance venue. There's several multi-use programming spaces. Stormwater management that's handling both the on and off-site runoff is incorporated into this plan. And you can see, or maybe it's harder to see because of the scale of this, the roadway widening project that was completed. They ended up trying to maximize the area they were managing by super elevating the road and pushing all the runoff towards the site so it could be captured. So in terms of a stormwater approach, we partnered with a landscape architect for their design team focusing on prioritizing a way to do a green infrastructure forward solution at this park that complemented the park features. So what we ended up doing was a series of cascading rain gardens that bounded that 15th Street side of the site adjacent to the performance amphitheater. We also worked to have a pedestrian bridge that crossed over the rain gardens and swales that the public would use as they access the site to create a really big aesthetic as you walked onto the project. There was also a boardwalk over a rain garden that connected two different viewing areas or two different programming areas that could be utilized at the site. And additionally, we did utilize some subsurface storage in the area immediately in front of the amphitheater. And there was also another rain garden that was managing runoff from the street to the north. The takeaway here is that early engagement led to a real, a greater comprehensive site programming opportunity, I guess is the best way to describe it. Department of Public Works, they were able to take on costs related to some of the site improvements that were tied directly to putting the stormwater or green infrastructure practices on the site. And the Department of Public Works was able to unlock funding opportunities that wouldn't be available for traditional redevelopment projects. They could and did apply for state revolving fund loans and other grant monies that were awarded to the project and helped finance the project. This allowed those other project stakeholders to reallocate some of the funding they had and think bigger. And the biggest example of that on the site is thinking through that state-of-the-art performance amphitheater that you can see in these photos. So with the incorporation of green infrastructure, with the other site programming features, and the mutual benefits that got shared by all the stakeholders, the green benefits of managing things both on and off site in terms of stormwater management, it helped the city reach all kinds of good goals. And just, I guess, for other engineers, designers out there, for some context from a green infrastructure impact, this site ends up managing over 100,000 square feet of impervious areas, and in a 1-inch storm event, you're managing about 38,000 gallons of stormwater. So as I wind down, I kind of wanted to spend a minute just recapping some of those learning objectives, and hopefully folks that have been listening, whether you're brand new to green infrastructure design or you're more experienced with it, I hope you found something that was of value to you listening to this conversation. And I guess at this time, I'm happy if there are questions from folks or things they want to share or discuss, you can do that at this time. And if we get short on time, feel free to reach out to me via email, and I'll do my best to reach back out to folks with a response.
Thanks so much, Matt. We had a bunch of questions come in. I think we'll only have time for one or two, but like you said, we can get to some of them offline. So let's see. In your experience, or based on your knowledge, how do major cities fund the maintenance of GI practices?
So that answer can vary depending on, I think, who ends up utilizing the space. Sometimes it's built into their operations budgets. So for like the parks examples I was just describing in Wilmington, they already have folks that are responsible for maintenance. Here it was, are there additional items that can be brought into that already existing maintenance contract to help make sure that things get maintained properly? In other instances, I know some places utilize stormwater fees, and that can be a driver for paying for things. Yeah, I think it's really dependent on what the municipality has in mind.
Yeah, absolutely. And kind of going off of that, does the maintenance of the green infrastructure generally get transferred to the city or county in perpetuity, or who is responsible for that maintenance in your experience?
I guess I can share a story associated with that too. One thing that we've found is that there are often green infrastructure practices that are installed on sites where the municipality isn't aware of them, but ultimately, because they're in the right of way, they end up being the responsible parties for maintaining and learning about them. And one of the things that we experience regularly is municipalities will reach out and say, we didn't do this, we're not really sure what it is. Are there typical maintenance practices that you can recommend? What's a program that we can develop? So yes, if it's in the right of way, oftentimes it's the municipality's responsibility for it. Some of the ones that are outside of the right of way, oftentimes we see folks that try to collaborate and ultimately have the property owners or community groups be more involved. Hopefully that helps answer that question.
Yeah, definitely. And I am afraid we've run out of time for questions today. For those that we didn't get to answer, we will get back to you via email. Thank you so much, Matt, for sharing all of that insight and information with us. It was really great. So thank you. And just a reminder to all of our audience, at the conclusion of this session, you will receive an email with a link to download your certificate to use for that Stormwater University credit or 1 personal development hour. Again, thank you to Matt, and do not miss our next session, which is a panel addressing emerging contaminants in the water industry. You can join that session by exiting out of this one, going back into the agenda and selecting that session. I hope to see you there. Thank you all again for attending.